The National Electrical Code provides guidelines for the use of plenum-rated cable in raised floor environments. Plenum-rated cable is fire-resistant cable that must meet specific criteria to prevent the spread of flames and smoke in plenum spaces. Plenum spaces are defined as enclosed spaces within buildings that contain electrical equipment and cables such as raised floors. NEC Article 300.22 C3 requires plenum-rated cable to be used within raised floors and computer rooms and other areas where it is circulated through the plenum space. NEC Article 800.110 requires plenum-rated cable to be used for station cabling that extends outside of the plenum space, such as to the general space. Based on the NEC requirements, you need to use plenum-rated cable for station cabling that needs to run outside the raised floor, which is the plenum, to the general space, even if the cooling output is only for the computer room. The reason is that the cable running outside the plenum is still exposed to potential fire hazards and could contribute to the spread of flames and smoke in the event of a fire. Plenum-rated cable is designed to minimize these risks and ensure safety in the entire building. In summary, the requirement for plenum-rated cabling extends beyond the physical boundaries of the raised floor itself. This is because the National Electrical Code, or NEC, prioritizes overall building safety and aims to prevent the spread of fire and smoke throughout the entire structure. So, let's look at the key aspects of the NEC requirements related to plenum spaces and cabling. Firstly, the definition of a plenum space is crucial. Plenums are essentially enclosed spaces within a building used for air handling. Common examples include the space above suspended ceilings, under raised floors, and within ductwork. These spaces are used for heating, ventilation, and air conditioning, or HVAC, systems to distribute air throughout the building. Secondly, the role of plenum-rated cable is critical. Standard cable, when exposed to fire, can release toxic smoke and spread flames rapidly. Plenum-rated cables are specifically designed to resist burning and to emit minimal smoke. This is crucial in plenum spaces because any fire or smoke can be quickly distributed throughout the building via the HVAC system, endangering occupants. Thirdly, NEC Article 300.22 C addresses wiring methods and materials in duct plenum spaces and other air handling spaces. This article mandates that only certain types of wiring and cabling are permitted in plenum spaces. Specifically, it requires that cables installed in these spaces must be either plenum-rated or enclosed in a metal raceway. This ensures that any potential fire hazard is minimized. Fourthly, NEC Article 800.110 focuses on communication cables, including those used for networking and data transmission. This section reinforces the requirement for plenum-rated cables in plenum spaces, particularly when these cables extend beyond the plenum into other areas of the building. It is important to understand that even if a cable runs only a short distance outside the plenum, it must still be plenum-rated for its entire length. This is because a fire within the general space could easily ignite the non-plenum-rated portion of the cable, leading to the spread of fire and smoke through the plenum and the rest of the building. Therefore, using plenum-rated cable ensures a consistent level of fire resistance and smoke reduction, regardless of where the cable is located. Fifthly, compliance with local codes and inspections is essential. While the NEC provides a national standard, local building codes and regulations may have additional requirements or interpretations. It is always advisable to consult with local building authorities and electrical inspectors to ensure full compliance with all applicable regulations. These authorities can provide specific guidance on cable selection and installation practices that are relevant to the local environment. Sixthly, consider the implications of using non-plenum-rated cable in plenum spaces. Using non-plenum-rated cable in plenum spaces can have severe consequences. Firstly, it poses a significant fire safety risk, as these cables can contribute to the rapid spread of flames and toxic smoke. Secondly, it can result in code violations, leading to fines, penalties, and a need for costly rework. Thirdly, it can void insurance coverage in the event of a fire, leaving the building owner liable for extensive damages. Lastly, be aware of the long-term cost savings of using plenum-rated cable. While plenum-rated cable may have a higher initial cost compared to non-plenum-rated cable, the long-term benefits outweigh the expense. These benefits include enhanced fire safety, reduced risk of code violations, and improved protection of property and occupants. In conclusion, the requirement to use plenum-rated cable for station cabling that extends outside a raised floor to the general space is driven by the NEC focus on comprehensive fire safety. By using plenum-rated cable, you minimize the risk of fire and smoke spreading throughout the building, ensure compliance with electrical codes, and protect the safety of building occupants. It is a critical consideration for any building with a raised floor or other plenum spaces. Remember to always consult with local authorities and qualified professionals to ensure full compliance with all applicable regulations and best practices. Additional considerations include cable management practices. Proper cable management is crucial to maintaining the integrity and safety of cabling systems, particularly in plenum spaces. Firstly, cable support and securing should be used to prevent excessive sagging or strain on cables. This helps to prevent damage to the cables and ensures that they remain properly positioned. Secondly, cable routing should be planned carefully to minimize the risk of physical damage or interference with other systems. Cables should be routed away from heat sources, sharp edges, and areas where they could be easily damaged. Thirdly, cable labeling should be implemented to facilitate easy identification and maintenance. Clearly labeled cables can save time and effort when troubleshooting or making changes to the cabling system. Furthermore, you should consider the impact of future expansion and upgrades. When designing and installing cabling systems in plenum spaces, it is important to anticipate future expansion and upgrades. Firstly, consider the capacity of the cabling system to accommodate future growth. Ensure that there is sufficient space and capacity to add new cables as needed. Secondly, standardized cabling practices should be used to facilitate future upgrades and modifications. Using consistent cabling standards makes it easier to add, remove, or replace cables without disrupting the entire system. Thirdly, documentation should be maintained to provide a clear record of the cabling system configuration. Up-to-date documentation is essential for planning and executing future upgrades and modifications. Material selection is another important factor in addition to plenum rating. Choice of materials used in cabling systems can have a significant impact on their performance and longevity. Firstly, copper versus fiber optic cable should be compared depending on the application. Copper cables are suitable for many applications, but fiber optic cables offer higher bandwidth and longer distances, making them ideal for high-speed data transmission. Secondly, the quality of connectors and termination hardware should be considered because it can affect the reliability of the cabling system. High-quality connectors and termination hardware ensure a secure and reliable connection. Thirdly, environmental factors such as temperature and humidity should be accounted for to ensure that the cabling system can withstand the operating environment. Cables should be selected that are suitable for the specific environmental conditions in which they will be installed. Regular maintenance and inspection practices can help to ensure that cabling systems in plenum spaces remain safe and reliable over time. Firstly, visual inspections should be conducted periodically to check for any signs of damage or degradation. Look for frayed cables, loose connectors, or any other visible signs of problems. Secondly, cable testing should be performed to verify the performance of the cabling system. Cable testers can be used to measure signal strength, attenuation, and other parameters to ensure that the cables are functioning properly. Thirdly, cable cleaning should be done to remove dust and debris from the cables and connectors. Dust and debris can interfere with the performance of the cabling system, so regular cleaning is important. Remember that safety precautions should be followed when working with cabling systems, especially in plenum spaces. Firstly, electrical safety procedures should be adhered to avoid the risk of electric shock. Always disconnect power before working on any electrical equipment. Secondly, personal protective equipment, or PPE, such as gloves and safety glasses, should be worn to protect against potential hazards. Thirdly, fire safety procedures should be implemented to prevent the risk of fire. Avoid using open flames or other ignition sources near cabling systems. In summary, understanding the NEC requirements for plenum-rated cable is crucial for ensuring fire safety and compliance with electrical codes. By using plenum-rated cable and following proper installation and maintenance practices, you can protect building occupants and property from the risks associated with fire and smoke. Always consult with local authorities and qualified professionals to ensure that your cabling systems meet all applicable regulations and best practices. You should consider the specific needs of the computer room environment. Computer rooms often have unique environmental requirements that can impact the selection and installation of cabling systems. Firstly, temperature and humidity control is critical in computer rooms to prevent equipment failures. Cabling systems should be selected that can withstand the temperature and humidity levels in the computer room. Secondly, airflow management is essential for dissipating heat generated by computer equipment. Cabling systems should be installed in a way that does not obstruct airflow. Thirdly, electromagnetic interference, or EMI shielding, should be used to protect sensitive electronic equipment from interference. Cabling systems should be shielded to minimize the risk of EMI. Also, consider the impact of cable pathways on building aesthetics. Cable pathways can have a significant impact on the appearance of a building, so it is important to consider aesthetics when planning cable installations. Firstly, concealed cable pathways should be used whenever possible to minimize the visibility of cables. This can be achieved by running cables behind walls, above ceilings, or under floors. Secondly, cable trays and conduit should be painted or finished to match the surrounding environment. This helps to blend the cable pathways into the building's design. Thirdly, cable routing should be planned to minimize clutter and visual distractions. Cables should be routed in an organized and aesthetically pleasing manner. When it comes to documentation and labeling best practices, thorough documentation and labeling are essential for maintaining and troubleshooting cabling systems. Firstly, cable identification should be implemented using a consistent labeling scheme. Each cable should be clearly labeled with a unique identifier that corresponds to its function and location. Secondly, cable pathway documentation should be created to provide a detailed record of the cable routes. This documentation should include diagrams, maps, and other information that can be used to locate and trace cables. Thirdly, cable termination records should be maintained to document the connections and terminations of each cable. This information is essential for troubleshooting and making changes to the cabling system. Also, consider the benefits of structured cabling systems. Structured cabling systems offer a standardized approach to cable installation that can improve performance, reliability, and maintainability. Firstly, standardized components should be used to ensure compatibility and interoperability. Structured cabling systems use standardized cables, connectors, and patch panels. Secondly, hierarchical cabling topology should be used to simplify cable management. Structured cabling systems use a hierarchical topology with horizontal and vertical cabling runs. Thirdly, centralized cable management should be implemented to facilitate easy monitoring and control. Structured cabling systems use a centralized patch panel to manage all of the cables. Consider the impact of cable bend radius on signal integrity. Cable bend radius is the minimum radius at which a cable can be bent without damaging it or degrading its performance. Firstly, manufacturer's specification should be followed for cable bend radius. Each cable has a specified minimum bend radius that should not be exceeded. Secondly, cable bends should be minimized to reduce the risk of signal degradation. Excessive bending can cause signal loss and interference. Thirdly, cable support and securing should be used to maintain the proper bend radius. Cables should be supported and secured to prevent them from being bent too sharply. Furthermore, cable grounding and bonding techniques are important for electrical safety and signal integrity. Firstly, grounding electrodes should be used to provide a low impedance path to ground. Grounding electrodes should be installed in accordance with the NEC. Secondly, bonding conductors should be used to connect all metallic components of the cabling system to ground. Bonding conductors should be sized and installed according to the NEC. Thirdly, surge protection devices should be used to protect equipment from voltage surges. Surge protection devices should be installed at the service entrance and at any other points where equipment is vulnerable to surges. In addition, you should consider the environmental impact of cabling materials. Cabling materials can have a significant impact on the environment, so it is important to consider sustainability when selecting cables. Firstly, recycled materials should be used wherever possible to reduce the demand for virgin resources. Look for cables that are made from recycled copper, plastic, or other materials. Secondly, low smoke, zero or halogen, or LSCH cables should be used to minimize the release of toxic fumes in the event of a fire. LSCH cables are made from materials that do not produce significant amounts of smoke or harmful gases when burned. Thirdly, cable waste should be recycled properly to prevent it from ending up in landfills. Contact a local recycling center to find out how to recycle cable waste. It is important to stay up to date on the latest advancements in cabling technology. Cabling technology is constantly evolving, so it is important to stay informed about the latest developments. Firstly, industry publications and trade shows should be consulted to learn about new products and technologies. These resources can provide valuable insights into the latest trends in cabling. Secondly, training courses and certifications should be taken to enhance knowledge and skills. Many organizations offer training courses and certifications in cabling installation and maintenance. Thirdly, professional organizations should be joined to network with other professionals and stay informed about industry best practices. Also, consider the importance of cable testing and certification. Cable testing and certification are essential for verifying the performance and compliance of cabling systems. Firstly, cable testers should be used to measure signal strength, attenuation, and other parameters. Cable testers can provide detailed information about the performance of the cabling system. Secondly, certification programs should be used to ensure that cabling systems meet industry standards. Many organizations offer certification programs for cabling installers and technicians. Thirdly, test results should be documented and maintained for future reference. Test results can be used to troubleshoot problems and verify the performance of the cabling system over time. You should also consider the use of cable management software. Cable management software can help to track and manage cabling assets, simplify troubleshooting, and improve overall cable management efficiency. Firstly, asset tracking features should be used to maintain an inventory of all cables and equipment. Asset tracking features can help to locate cables and equipment quickly and easily. Secondly, troubleshooting tools should be used to diagnose and resolve cabling problems. Troubleshooting tools can help to identify the cause of a problem and guide the user through the repair process. Thirdly, reporting capabilities should be used to generate reports on cable usage, performance, and compliance. Reporting capabilities can provide valuable insights into the overall health of the cabling system. It is also important to comply with Americans with Disabilities Act, or ADA, guidelines for cable pathways. ADA guidelines specify requirements for cable pathways to ensure that they are accessible to people with disabilities. Firstly, cable pathways should be located in accessible areas. Cable pathways should be located where they do not obstruct the path of travel for people with disabilities. Secondly, cable pathways should be free of obstructions. Cable pathways should be free of any obstacles that could impede the movement of people with disabilities. Thirdly, cable pathways should be clearly marked. Cable pathways should be clearly marked to warn people with disabilities of their presence. Finally, consider the use of pre-terminated cables. Pre-terminated cables offer a convenient and time-saving alternative to traditional field-terminated cables. Firstly, reduced installation time should be considered when using pre-terminated cables. Pre-terminated cables can be installed much faster than field-terminated cables, saving time and labor costs. Secondly, improved performance should be considered when using pre-terminated cables. Pre-terminated cables are manufactured under controlled conditions, which can result in improved performance and reliability. Thirdly, reduced waste should be considered when using pre-terminated cables. Pre-terminated cables are manufactured to the exact length required, which can reduce waste and disposal cost. Remember, some jurisdictions may have additional requirements or interpretations of the NEC. It is always recommended to consult with local building authorities for specific guidelines.